Hello friends, you are welcome again on our channel SK Learn, and today we are going to learn the ARIMA result explanation. I'm sure you all have done the time series. If you have not done, please follow our previous video. What is time series and what is the importance of the ARIMA? Because this is very important to learn what result you have received and how to interpret that result. Otherwise, there is no benefit to do that codings if you don't know what is the end result. ABC, how to interpret the ARIMA result. It's a very essential to understand how to analyze the ARIMA result. In this video, you will learn first to examine the general information, review the coefficient for the significance, understand how to determine if our result meet the model assumption or not, and then compare the various results. If we talk about the ARIMA, this is the uh, you can say this is made by the three components. It's a P for autoclusive, ARIMA for autoclusive, integrated, it's a D, and moving average, it's a Q. P, T, and Q. How Arimax and Sarimax flow? If you see the overall map, so you will notice there are three circle which is made handmade. First is there is no color, second is below, and third is some orange. So if you see the second one, the blue light one, it's the ARIMA for time series plus seasonality handling and plus seasonals. It is this three calls ARIMA. If we see the third one, where we use the end result of the ARIMA, that is seasonal SARIMA. So SARIMA plus linear regression that made the linear regression with the seasonal ARIMA errors. That will say us, that will show the result, how model fit, what is the errors there, and how can we improve this. So that's the same thing ARIMA result we are going to learn today. If you will see the ARIMA result, I'm sure if you have done the Python codings for the time series, at the result of ARIMA codings, you will see something like similar, right? So I can divide that result into three parts. First, no, actually we can divide that into the four part. First is general information, that is very general. We will go in a deep. Second is a term significant. Third is a assumptions. This is actually a result, so which we will analyze. And fourth is a fit analysis, how our ARIMA is fit in our model analysis or our objectives. Let's see this one by one. What is first? After creating an autoregressive model, check the result to see if the model makes sense and how well it performs. Using state models or any other library will print the something like that below. The best way to understand our result, we will review the result as a simple of AR model trying to predict Bitcoin's future result using these steps. First is review general information, second is determine the term significance, third is analyze model assumptions, and fourth is compare the result. So let's see one by one. First, review general information. You will notice one thing whenever you run the ARIMA model, but at the top you will see Sarimax. So that's you know that because you will see the second model is ARIMA. You can see that, right? General information. If you can see the all the yellow highlighted one, that is our one first criteria. General information. We will see the deep depth variables, models, date, time, sample, and number of observations. If we I try to analyze these one by one. So what is step variable? This is what we are trying to predict. Model, the type of the model. So you will see the actually your model name is here. If you are trying to do ARIMA, you will see ARIMA there. If you will see AR, you will see AR there. If you are trying to do MA only, you will see MA there. Moving average. Date. The date within the model. Time. The time of the model finished. Sample size. It's a range of the data from this date to this date. This is actually sample. This is sample size, right? So you can see here we are evaluating our data from the 1st of April 2020 to 17th of January 2021. Number of observations. So in this model, we can see our observations are 1751. The dependent variable is closed, which are trying to predict. The independent variable are the constant beta. Error term is sigma 2. So all these three, dependent, independent, constant beta, sigma 2, or all sort, or the log variable L1, L2, L3, this you will see in the next page. That is our second criteria determining term significance, right? First criteria we have here the general information. If everything is good in general information, we are not seeing anything which is missed out. So we can move to second things that is term significant. Now we want to make sure each term in our model is statistically significant. The null for this section is that each coefficient is not statistically significant. Therefore, we want each term to have a p-values less than 0.05. So we can reject the null hypothesis with the statistically significant values. In our examples, you can see the L1, L2, L3. If you will notice that the p value you can see is here. The p value for the L1 is 0.164, for L2 is 0.706. This is all both more than 0.05%. So we are not matching, right? So we are not matching this, right? If we move to third, that is review assumptions. In the last sections, it's not last, after that we will do the fit analysis. We want to make sure our model meets the assumptions that residuals are independent, none as a white note. If the residuals are not independent, we can expect the non-randomness to make the better model. So there's a white note. If we see, there are many things. We can see the junk box is there, hetero density is there, Java Vera is there, SQ is there, Kukul's is there. So let's see one by one. Junk box. Test pronounce the young and sometimes called the modified box species test. It tests the error at white note or not. In our model, we can see the value is 0.01 and the p-value is 0.94. See, the junk box is value is 0.01 and p-value is 0.94. Since the probability is above the 0.05%, so we can reject the null hypothesis. We can't reject the null hypothesis that the errors are white note. If you are interested to see all the things, so you can go more the details about this. Second one, heterodoxity. It tests the error residuals are homoscedasticity or have the same variance. The summary performs wide stats. Our summary statistical show the test statistics of 1.64 and a p-value of 0.00, which means we reject the null hypothesis and our residuals show variance. This variance poses forecasting problem if you go with this data. Third one in Jalcuvera. Jalcuvera test for the normality of the errors. It tests the null that data is normally distributed against an alternative of another distribution. We see a test statistical of 4535.14. You can see in the result. It's a 4535.14 with a probability of 0, which means we reject the null hypothesis and data is not normally distributed. Also, as a part of the Jarque-Vera test, we see the distribution has a slight negative skew and large tutorials. You can see tutorials is only the 10.87. We now move to last one, that is fit analysis. So this section of a result called always fit, where we see the log likelihood, AIC, BIC, and HQIC. Let's see this one by one. What is this? If we see the log likelihood, the function identify a distribution that fits best with the sample data. While it's a useful, AIC and the BIC punish the model for complexity, which help us make our ARIMA. If we go for the second result, you can see here AIC. AIC is it's a negative 10164. So what is that? It's a Kaike information criterion. AIC helps determine the strength of the linear regression model. The AIC penalizes a model for adding parameters, since adding more parameters will always increase the maximum likelihood value. If we see the third one, that is BIC. BIC is a Bayesian information criterion. It's same as the AIC. Also punish a model for the complexity, but it also incorporate the number of rows in the data. If we see the third one, HQIC, it's a hand and Q information criteria. It's also same as like AIC and BIC. It's another criteria for the model selection. However, it's not used often as a practice, but we will see this here. That's why we are studying here, right? So hopefully you can see now we have analyzed all the four things here, how our model should be explained. First, general information, second, term information, third, assumptions, and four, fit analysis. After that, only we can decide we should move forward or not. Otherwise, we will improve our model first. Hopefully, this will help you to understand the ARIMA model. Thank you. Thank you so much. Thanks. Bye. And give us support to like and subscribe our channel.